fall sports. So what would that be? Football, of course, volleyball, cross country, bowling. Did I hit them all? I think so. If you're currently in a sport, you're probably in this. Ask your coach though, or ask your teammates. Okay, volleyball is a fall sport. Yeah. So anyway, Miss Overall will be sending a list out to your teachers so if you are in that group, I will have all of your teachers will have a list of who should be dismissed at 9:30, which is actually during third period. They will go down to the auditorium before. So don't stress if you are in that list of fall sport athletes and you're not here to take attendance. Don't worry, I'll see you after the pep rally and I'll fix the attendance. Okay, so don't worry about that. But everyone else should come here for attendance and then. Okay, so again, I won't be here Friday. I'm going to give you guys a worksheet to do, or my sub will. I will have a key for it, and she can actually help. We have a test next Thursday. Remember that whole Module 1 test on the computer and all that? There's like 12 of those in the whole school year, okay? So there's about 3 a quarter. So we've had 1, and we'll probably have, I think it's 2 more this quarter. At least next week we have Module 2. So we'll be doing exactly what we did last time. We'll be on Performance Matters, the whole 9 yards. We did it. You guys were really great about logging in and all that stuff. So that's next Thursday. So what I did, because I wasn't going to be here, I couldn't teach when I'm not here, is I made you guys a review that's kind of like a mini test review, just to kind of get you, reminding you of all the stuff we've done in Module 2. There might even be a sprinkling of Module 1 type questions like solving equations or something. But guys, take it seriously. I know I'm not here to yell at you to do this or do that or whatever, but take advantage of the day to just work on a review. I'll have a key up with all the work shown. You can copy it. I won't know. I don't have cameras in here. But guys, take it seriously. Like, help yourself be successful in this class. You've got to pass it to graduate. So don't shortcut it, okay? So next Thursday, we are definitely going to need our laptops. And I'll keep reminding you, okay? All right, so bell work. Intercepts. Intercepts are where the graph touches and or crosses the x and y axis, okay? So how many x-intercepts would you guys say are in this graph? How many? Keisha, how many x-intercepts are there? 2. And sometimes we have to name points that are not exactly at a crossing. So you can do the best you can. If you already wrote something and it's really close to mine, but it's not the same, you don't need to erase it, okay? In an x-intercept, are our x's 0 or our y's 0? Y's. Remember, it's always the other letter, okay? So this x-intercept is somewhere between 0 and 1. I don't know, call it 0.7, 0.8, 0.5, I don't care, okay? It's not quite at 1, though. And the other one, 1, 2, 3, 4, and a little bit more, right? Goes a little past 4. What is that little bit? Who knows? Who cares? But maybe you put 4.1, 4.2, 4.3. I don't care, okay? If you put 4, that's okay, all right? I wish they didn't do this to us, but they do, all right? How many y-intercepts do we have? 1, right there. So remember, in a y-intercept, the x value is the 0. And then we go down 3, so that makes it a -3. We should be really good at intercepts at this point. How many x-intercepts do we have on this graph? What do you think, Elisa? 3. Did you say 3? Yeah. 1, 2, 3. Again, they gave us some kind of tough ones, but let's just set it up. There's 3 of them. What I know for sure is all the y values are 0, right? And so we're going to the left, so these two will be negative. So negative 2.5 maybe. Maybe negative 1 for that one. And then 1, 2, 3, and a little more, 3.6, 3.5, maybe you wrote a 4. Okay, the point is that you know that there, right there, whatever that number is a x-intercept. That's really what matters, okay? And I think you guys would all agree that we have 1. Sorry, tell me when I do that, guys. You can't see what I'm writing. Tell me. y-intercept of, okay, you know for sure the x value is going to be 0, right? And then the y-intercept looks like around -1, maybe a little bit more, okay? Anybody have a question about intercepts right now? Can we make sure our reference sheets are out? I know it's dumb. It actually hurts me. It hurts my teacher heart to have to ask you guys to do it because it's so dumb. It's so dumb. But I have to do it. Like, there are things that my bosses tell me I have to do even though they think it's dumb. I'm not your boss, but as your teacher, there's certain things I have to ask you to do. We're just going to keep doing it. Someday, there's going to be a magical day where I say, guess what, guys? You have your reference sheet out for an actual reason this time. We're going to use it. Okay? So, but that day is not today, but it still has to be on our desk. Okay. I think you guys are going to find this to be an easier assignment. Okay? So, getting used to using the book. We have to do a lot of flipping around, but I try to be very clear with you where we're going to be and what page and everything, okay? So we're starting 2.4 today, shapes of graphs. We'll do that today and tomorrow. And then we only have one more section left in this unit, 2.5, and we'll do that Monday and Tuesday. So I'm going to tell you ahead of time, because when I teach fourth period, I've already taught this class first period, so I can give you some feedback. I think first period thought this was pretty easy. The homework is very short. Most of my students had a lot of time left over at the end of doing the homework, okay? So I want to encourage you guys to start really using your time in here wisely. Were you absent a day this week? Maybe you need to go on Canvas and catch up. Did you not finish yesterday's homework? You got behind, or maybe I assigned more than, you were comfortable with, whatever it may be. Go back to yesterday's and did I finish yesterday's homework and stuff like that. Because as you guys are seeing, when I pass back those packets, there's a lot of you like, how did I miss those points? Why? And I wrote it all out for you. I would love to get to the point where you guys know exactly what you're turning in and all that stuff and make it easier on both of us. But we're working together right now. We'll get there eventually. So remember, when it comes time on Monday for you to turn stuff into me, I would love to just put 20 out of 20 or 24 out of 24 on all your papers. And I know that's what you want too. So just make sure if I write it down in the notes, it needs to be in your notes. If I do bell work, which we do almost every day, it should be in your pages wherever they are. It's my responsibility to find it. But if you're just following along and doing stuff with me, you're doing everything you need to do. If you missed it because you were absent, I do a video every time I teach. I upload the completed notes, I upload the homework assignment, and I upload the homework key. There's no reason for everyone not to get perfect scores on that packet each week, okay? So try to start training yourself to get in the habit of really making sure that every week you get those points, okay? All right, so here we go. Symmetry is what we're talking about, symmetry. There's all different types of symmetry in math. What we're talking about in here today, maybe it's the only symmetry, I don't know what happens down the road, but it's something called line symmetry. Line symmetry is a line, shocker, that makes it so the left side mirrors the right side. First of all, we need to know what a vertical line is. Okay? A vertical line looks like this, right? That's a vertical line. A horizontal line, we can just use this space over here to write a little something, looks like this, okay? We have to know the difference. And I'm going to come back to write something. Oops, sorry. I'm going to come back over here to write something in just a second. Okay, so what we have is a graph, right? And we should be able to look at this graph and find where the graph splits into two equal halves, left and right, which means there is a line of symmetry that goes right down the middle. Okay? Not all graphs have line symmetry. This one does. So to describe it another way, it's always a vertical line. Okay? It's always going to be a vertical line. And if I could cut this out of my paper, literally with scissors, and fold my graph right along the y-axis, all the points on the left would line up perfectly with all the points on the right. They would touch, okay? That is line symmetry. Okay? Look at this one. Here's another graph, And it doesn't have to be the y-axis. It can be, you see it there, but it could also be any vertical line. So you can see if I drew a line right through the middle, it would make the left side exactly the same as the right side. If I folded it, all those points would touch. Okay? That's line symmetry. It's very visual. So look at our first example. This is just a regular old line. This is linear, right? This is nonlinear. Linear, nonlinear. In this, guys, tell me what you think. Is there line symmetry in this line? Is there a place that if I drew an imaginary, like, vertical line, that if I folded it, all the points would touch? No. And that's kind of confusing, right? Because you could make an argument that if you drew a line, and I'm not going to do it, but if you drew a line like on the y-axis, this and this are like the same shape, right? They're the same, they're doing the same thing. They're just straight line. But they wouldn't touch if you folded it. So there is no line that can be drawn to make the right half a mirror image of the left half. So the function does not display vertical line symmetry. Okay? What about this one? Yeah, right? I can picture if I drew an imaginary line or drew a line right there and I folded my graph max head up. If I folded my graph on that line, all my points on the right would match up with all the points on the left. Okay? So this one does have line symmetry. Now we're going to take it a step further. What is that line? Well, anytime you have a vertical line, it's x equals whatever the x value is that vertical line goes through. That's the equation of this line. So what I want you guys to add to your little thing up here is all vertical lines will be x equals some number. That's number, not hashtag. Okay? Horizontal lines are y equals a number. Okay? But we're not worried about horizontal lines today. All of our symmetry is always vertical. Okay? Let's go to the next example. We had a similar word problem. Well, actually, we've had word problems before, and then we had a graph or a table of values to go with it. Okay? And that's what we're looking at here. So let me read to you. A fountain is spraying a stream of water into the air. The solid portion of the graph, so you can see that solid portion of the graph, represents the path of the water, where x is the distance, right? Here's distance, and y is the height. So distance in feet, height in feet from the stream. So it shoots out the water. And why is this graph only solid in quadrant 1? Remember, this is quadrant 1. Well, as I told you guys yesterday, in word problems, you almost always, I want to say 99.9% of the time, you only will use quadrant 1. And usually, like, this is time and this is distance. We don't use the other 3 quadrants. That's why they're like dotted, dashed lines. Because we don't have negative distance or negative time. That doesn't make sense. You don't travel somewhere a negative amount of miles or have a negative amount of time. That's why we're only caring about that little part of the graph. So the right half of this whole graph is the mirror image of the left half in what line? Can you guys tell where the middle of that graph is? 2. Very good. So you can kind of see like that highest point right there. What? I know what you're going to say because I looked at that graph earlier and thought the same thing. I think I know what you're going to say. I don't want to say I know what you're going to say. It is 2 because what I did when I first looked at it, I was looking at just the distance, look, from 0 to here. But actually, the graph does go over here, okay? So it's actually the halfway point between the whole thing, okay? This is just the part that pertains to this word problem. So 2 is the middle of the 2 halves, okay? Now, you have a homework problem in a few minutes. Listen, you have a homework problem in a few minutes, 1, which is like this, where you have to find the axis or the line of symmetry, okay? You name it. And then you have to, in your own words, explain what it means, okay? So remember, when you have to explain in your own words, I don't care about grammar, I don't care about spelling, As long as you can get your point across, that's all that matters. So let's see what the book says that means. In the context of the situation, the symmetry of the graph tells you that the height of the stream of water, when it's from 0 to 2 feet away from the fountain, is the, what am I saying here? Is the same as the height of the stream of water when it's from 2 to 4 feet away. What I'm saying is this. What this is saying is this is the same as this. That's what that's saying. These are the same distances. Okay? What I want you to get out of this is that a line, that symmetry line of symmetry, splits your graph into 2 equal parts. So everything that happens on the left, the same amount of that would happen on the right. Okay? So the 0 to 2 matches 2 to 4 on the other side. Okay? Last example, my darlings. We're learning a new word today called extrema. Okay? We go deeper into extrema tomorrow. Okay? Deeper into extrema tomorrow. But let me just tell you what extrema are. Extrema is an umbrella term for special points on a graph. Where your graph changes direction is called like a turning point. Those are called relative mins and maxes. And we'll come back to that more in a minute. Really today is about where the graph goes up and goes down. So a function is increasing when it goes up. So if it's going up, we call that increasing. That's it. Okay? And where a graph is decreasing, it's where it goes down. So increasing up, decreasing down. Pretty simple. So if you look at this graph, watch, and we always go left to right. From where I'm starting at this arrow, I'm decreasing, right? I'm decreasing. When I get to this turning point, which we'll go deeper into that tomorrow, that's called a minimum. When I get to that turning point, I change directions, and then I start increasing. When I get to this turning point, known as a maximum, I change directions again, and then I'm decreasing. So decreasing, increasing, decreasing. Now, what makes this tough is not that. I don't think anyone looks at that and doesn't understand up and down. It's how you have to answer the question. So please listen. Final example. We're going to look at this graph and decide where it's increasing or decreasing. So just if I did it verbally, everybody look at my pen right here. If I start here, are we decreasing? Are we increasing or decreasing right where my pen is? We're decreasing, right? We're going down. We hit this turning point and we start increasing. So we're going down, we're going up. Decreasing, increasing, right? That concept. Where does that happen? How do we answer correctly? Because math's all about the language. We have to answer the question correctly. How do we state what part of the graph is decreasing and what part of the graph is increasing? That's what's tricky. So listen, just like when we had to say where we were positive or negative, it's all about the x value. So figure out where my turning point is. Where do things change? Things change right here, right? That's where we change direction, decreasing to increasing. Think about what that ordered pair is. It's 0, what is that, -3. We always use the x value to name it. So where are we going down? Where are we decreasing? What are those numbers? Are they greater than 0 or less than 0? Less. Remember, if you're going to the left, that's less than. So all the numbers that are less than 0 are, oops, sorry, I have it backwards. Sorry, don't write that. All the numbers that are less than 0 are decreasing, right? Those are decreasing points. What points are they? All the numbers to the left of or less than 0, okay? So the opposite is true here. For this part of the graph, we are increasing, and it starts at 0, right? Still using 0. You don't use the -3. You always use the x value. All the numbers to the right of 0, which is greater than. So this would be x is greater than 0, is where we are increasing, okay? That notation can be confusing. let's look at this one. Last one, and then I'll give you your homework. So all it's asking for is when x is greater than 1. Where are they talking about x is 1? Oh, this point, right? Increasing, decreasing. We're increasing over here, we're decreasing over here. Where did they get the 1? Because that's the x value where that changes, right? 1, whatever. So we're talking about when x is greater than 1. What do we think? Are we increasing or decreasing when x is greater than 1? It's tricky because these arrows are pointing down. But think about it. Right there where it changes, that's the numbers to the right, right? This is where x is greater than 1, right? These numbers right here are where x is greater than 1. Because don't forget, as this goes down, it's also going to the right. So the x values are getting bigger as the y values get smaller. So are we increasing or decreasing when x is greater than 1? Decreasing. That's tricky. Really have to understand the notation. This is not the type of stuff where you can just like memorize. Oh, it always does this, I do that. It always does this. You have to really understand what it's asking. When my x values are greater than 1, that's the numbers going this way, right? X is greater than 1 going this way. What is the graph doing right there? It is decreasing, okay? So try to understand the concept. So tomorrow we'll go deeper into extrema, okay, and where those turning points are. Okay? So your classwork, guys, label it. Circle those problems. Then when you go to turn your work in on Monday, you can, or on Friday you finish your homework early, today you finish your homework, whatever, go back through. You can say, oh, did I finish all those problems? A lot of you got incomplete last week because you'd leave off the last 2 problems. You do like 1 and 2, and then you'd forget to do the rest of them. So you got incomplete. So whatever you need to do to know in your own packet, like what problems I'm supposed to do, circle them. Number 6 is the only one that you have to do an explanation in your own words. So I'm going to let you get started, and then I will put the key